Thanks for sending your question. If we're going to graph this expression, the very first thing we need to do is to start factoring it. So let's go ahead and do that. As you can see, the top is a difference of cubes. 1 is technically 1 cubed. We have a special way to factor those. So this will factor into x minus 1 times x squared plus x plus 1. On the bottom, we can factor out this x, and we'll end up with x times x squared plus 1. Oh, x squared minus 1, excuse me. And on the bottom, we can go ahead and factor this difference of squares again. So we end up with x minus 1 times x squared plus x plus 1 over x times, and this difference of cubes will factor into x plus 1 and x minus 1. Okay, to find the denominator, we're just going to go ahead and set to find the domain, we're going to go ahead and set the denominator equal to 0, which will be very, very easy to solve for now that we have this factored. If we're going to solve this equation, we just go ahead and set each of these factors separately equal to 0. And if you do that, you'll end up with x equals negative 1, x equals 0, and x equals 1. So if we go ahead and put our denominator into interval notation, or our domain into interval notation, pardon me, we're going from negative infinity all the way over to negative 1, and we are not including negative 1 because our denominator is not allowed to equal 0. So we're excluding that from our domain. Then we're going to go from negative 1 to 0. 0, of course, again, is not included. And then we'll be going from 0 to 1, not included. And then we're going from 1 all the way out to positive infinity. So that would be the domain of our expression. The next thing we're going to do is we're going to cancel the common factors. That will help us find our holes in our graph. Our holes exist at the common factors, so we have holes at x equals 1. After we cancel, we can rewrite this expression as x squared plus x plus 1 over x times x plus 1. To find the y value of your hole, just go ahead and plug this value into this expression. And when you do that, you'll end up with a 3 on the top and a 2 on the bottom. So your hole is at 1 3/2. Anywhere you have a hole, you can go up to these values and you can cross this one out. And this will help you find your vertical asymptotes. Your vertical asymptotes exist on your non-crossed out values. So I have vertical asymptotes at x equals negative 1 and x equals 0. So next we're going to go ahead and find our horizontal asymptotes or our slant asymptotes. You will either have one or the other. You will never have both. So you're going to have a horizontal asymptotes if your leading degree, meaning the largest exponent of your top and your bottom, are the same. So in this case, I have a leading degree of 3 on the top and a leading degree of 3 on the bottom. So I am going to have a horizontal asymptote. You will have a slant asymptote if your leading degree on the top is only 1 more than your leading degree on the bottom. So for instance, if I had a leading degree of 4 on the top, that would be a different story. So if you have a horizontal asymptote, you can find it by taking your leading term of x on the top and dividing it by your leading term of x on the bottom. If we do that, in this case, we'll end up with 1. So we have the horizontal asymptote at y equals 1. Let's go ahead and find our intercepts now. We'll have x-intercepts where y equals 0 and y-intercepts where x equals 0. Y-intercepts are easier, so let's go ahead and find those first. To do that, we would just plug in x equals 0 to our expression. So if we go up to our new expression and we plug in x equals 0, well, we can't do that because then we'd end up with a denominator of 0 and we're not allowed to divide by 0. So we have no y-intercepts on this graph. Now let's go ahead and plug in y equals 0 to find our x-intercepts. If we plugged in y equals 0 over here, we could cancel the denominator theoretically, and we would end up solving the equation x squared plus x plus 1 equals 0. Now to see if this even has a solution, I'm going to go ahead and use what's called the discriminant. The discriminant is the square root part of the quadratic formula. So it's the square root of b squared minus 4ac. If we just go ahead and plug a, b, and c in here, we'll get b squared, so 1 minus 4 times a and c are all 1. We get a negative underneath the square root, so we'll get some kind of complex number or something, and we're not allowed to have complex numbers on this graph. So when that happens, what that means is that you don't have any x-intercepts. All right, so we're ready to graph this now. Let's go ahead and graph our vertical asymptotes first. We have a vertical asymptote at x equals 0 and x equals negative 1. I'm going to set this up so that this value over here is equal to negative 1. So we'll just be going by 2's here for every interval. So this will be x equals negative 1, and then we also have a vertical asymptote at x equals 0. And make sure you label those in your graph. Now let's go ahead and graph our horizontal asymptote. We have a horizontal asymptote at y equals 1. So we're just going to draw a horizontal dotted line now. And this will be y equals 1. All right, now let's go ahead and put the hole in our graph. Our hole is at 1 3/2. So we'll go up to 1 and then to 1.5 here. And that's where our hole is. The next thing we're going to graph is our ends, meaning we're going to graph what's on the outside over here, and then we'll graph what's in between these two vertical asymptotes here. On the outside, you kind of just have these backwards C shapes, and they're not that hard to graph. You just need to figure out kind of which one of these 4 areas we're going to be in. So are we going to be here, 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 or here? Well, I have a hole in my graph up here, so I know my graph is going to be, part of my graph is going to be up here. So I've got this going on up here in this quadrant, and then on my other side, it'll either be up here or here. To find out which side it's on, just go ahead and plug in a value. I plugged in x equals 2. So if you plug in x equals 2, you get y equals 3/2. So since I got a positive value, that means I'm up here and not down here. So 1, 2, and then I'm at 3/2. So I am over here. Got a point in my graph right there. And I'm just going to draw another little backwards C-shape thingy with some arrows on the ends. The very last thing we need to graph is our, what I call our in-betweens. They're in between your vertical asymptotes. They will always be parabolas. So to figure out where this is going to be and which direction it's going to be, we're going to plot a point. It looks like I have half a unit here and half a unit here. So if I have a parabola in here, I'm going to have an axis of symmetry in between these two. So but the vertex of my parabola will be at x equals -5. Or -0.5, I apologize, -0.5. If you go ahead and plug -0.5 into your equation up here, you'll get y equals -3. Since you get a negative value and we don't have any x-intercepts, see, 1, 2, 3, we're going to have a downward facing parabola here. Okay, so that's the graph of this function. Thanks again for sending your question, and I look forward to answering more of your questions using SnapMath in the future.